Welcome back, everyone, to I think it is now episode 3. I know it's been a while since I have uploaded a video to the channel here. But today we are going to do a lot. It should be a longer one, I am hoping. So today I want to start making some metrics and maybe adding a better like not trashy um, strategy, because currently our strategies are just really basic, really boring. So adding a new strategy that is a little bit more realistic than just alternating or being always in. But today I want to focus on adding these metrics, and I already have added some of the functions that I want to add in today before I started recording. Just give myself a reminder of what I want. So this is it's going to replace what is going on right here as of right now. Um, and so it's not just a debug statement, and it is able to actually print these statements just in one file. So it's all centralized, and if there's any bugs, it can be fixed later, and for any additions later to the metrics, uh, it is very easily addable to to this file, because all you have to do is just add one more function and then throw that into the summarize, and we have a new metric. So as of right now, I did make one change a little while ago for the strategies here. Before, it didn't have a position, like the positions was empty, and it was for eye and range, just land bars. But there was one slight problem, is that it allowed the first position to also be in, which allowed for returns on this first bar, like on the first bar when um like allowed a lot of returns on the first bar because you were automatically already in for this always in strategy. And it also prevented a trade cost addition to the to the um to the bar as well, because it was already in, so it avoided the trade cost. Because if you look back in our simulate, it's only if the positions are not equal to each other you get the trade cost. So the strategy.py, the strategy, each strategy now starts at 0 by default. Now, these basic strategies, like the machine learning, since I do want to actually implement it into a real stock app, that you can actually use to trade online, um, it's probably not gonna remain, but just for basic back testing, testing for just the back tester, and my pipeline, uh, this is a this is going to be useful for now, because um, it also makes sure that the computer itself knows that the positions is going to start at 0. You're not going to just be in on 0. So it forces that. And it also allows for some sort of normalization between all strategies in that regard. Alrighty. Um, I think that's it for the um, for review there. I mean, nothing else I changed, so let's just go through and add the metrics. Alrighty, so let's get this started. I'm going to add a couple more functions here. We'll add final equity. Let's pass on that for now. And we'll also add an exposure. Depth exposure results. And we'll pass for now. Okay, so to start with, we need to import. We need to from simulate. It's from the backtest. Backtest.simulate. Import backtest result. And we want to do this because if you look back at our run pipeline, which we have already completed and it works, our result is a backtest result right here. We don't have to actually import it here because these are just these are running the actual simulate positions, which already has this backtest result since it's in the simulate.py file. But these metrics do not have that same access to it, so you have to directly import the backtest result for it to work. Because we are going to, the results itself, we are defining it as a backtest result. It's just for the sake of clarity for the most part, but that's I'm just going to go ahead and do that just to make the pylons happy for when I use for doing that. And then if we will also look back here, since we are using the backtest result, we can actually go through and look at the equity in specific, since that is just one characteristic of our backtest result. So for our final equity, this one isn't too hard. All you have to do is just return result dot equity at -1. And boom, we have our first metric there. We can go ahead and test that real quick. So here, I'll just start at the bottom for now. We'll just call it summary is equal to, we'll do summarize. Oh, we also have to make sure to import from backtest dot metrics imports summarize, and then is equal to summarize, and we'll just do result 1 for now. So we have that, and we can just print the summary. And then metrics. So first, before we actually go ahead and run that, we have to actually create a summary. So we'll just create the variable summary here, or we can just do return this dictionary, and we'll call this one final equity. We don't have to actually do it that way. We can just say equity. It is equal to final equity of results. And then since it's already returned, that should work. Let's see. Awesome. So yes, and it matches also the final equity that we had there previously. So that is the basic idea of all of these metrics there. Total return will have a similar vibe, return results dot equity of -1 over results. Oh, and also let me make sure to backtest result that result dot equity of 0 minus 1. And let me just do this all multiplied by 100 so you can actually get the percent return, which is not something that I had before. and then return, and then comma there, and then our total return is our total return of our results. There. Save that. Let's do it. Cool. And actually, I don't think we had that one before, did we? Result? No, we did. -1. Oh, okay. So it's 0.2% return, negative 0.2%, which makes sense. The loss was only like 3 out of 1,000, so our total return was like was negative 0.2%. And yeah, that makes sense. Sorry guys, I kind of messed up on my understanding of the max drawdown. So essentially, after going back and looking at it, a drawdown is actually like your biggest peak. It's a running peak. So like if you started at 100 and then it went down to like 90 and then it went down to 80 and then it went back up to 100, your biggest drawdown was just the difference between 100 to 80. But if it went down to 100 to 90, back up to 100 down to 80, like it's not going to include the 100 to 90. It's just going to be that 100 to 80, if that makes sense. So, I mean, to go back over it again, so like another example would be from like 100 to 50, back up to 120, down to like down to 0. Like your biggest drawdown is going to be that difference between 120 to 0, not the 100 to 50. Even though there's still big differences and had big risk, um, only that one from 120 to 0 is counted because the highest peak to trough difference in one run before like a positive gain is what is counted for the max drawdown. So we want to initially start with our first peak. We want to just define our variable. Our peak initially is just result dot equity of 0. That's just our starting point. And I need to finish typing result. And then our initial max drawdown, or max DD, is equal to 0. I'm shorthanding drawdown to DD because I'm lazy. And then we want to just loop through our equity list. So equity in result dot equity. Our peak is just whichever is higher, our current peak or the equity that we had, and that will. So if our equity started at, since our equity starts at 1,000 and it went down to it went down immediately to like 997, we'll say, our peak is still our result dot equity of 0, our initial equity, because that is higher than 997, obviously. And if it goes up, our new equity is going to be our new peak. So then our drawdown is just equal to equity over peak minus 1. So it's just the ratio of our current equity over our peak. And then our max DD is equal to and since drawdown is always negative, we want to find the whatever is smaller between our biggest drawdown and our drawdown, our DD. Whoops. And then we're just going to return max DD times 100 to give us the percentage of our drawdown. So to go over this one more time, we're tracking our peak through the equity list, and then our drawdown is just the equity over the peak. And so if equity is still greater than our peak, that is like so, and our new peak is going to be our equity anyway, so our drawdown is 0%. If so, drawdown can be 0 in that regard. And then our max drawdown. So if our previous drawdown was since our drawdown is meant to be negative, we want to find the minimum of our of the previous max drawdown, which starts at 0, and the new drawdown we had just calculated. And then we return our max drawdown times 100 to give the percentage value of our max drawdown. And then if we run it, perfect, and we get our max drawdown there, which is 0.38%. Okay, so now let's move on to mean return. I have flipped mean return and volatility around because by design, volatility is a function of mean return, and you will see why in just a minute. So first, our mean return, it is just returns is equal to results. Oh, let's also make sure that this is defined as backtest result. Before we start, as result dot returns. I also fixed the typo of summarize there, and our run pipeline as well. I had just realized I had made that typo. Anyway, so our returns is just equal to result dot returns, and then we'll do mean return is just equal to sum of returns over len of returns, and then return could just do Control X there. There we go. And then now all we have to do is just or let me go back. And we'll just do we'll call this mean return. It's a mean return of results. And then let's just run that. Awesome. So that just means we're not getting very much on returns then. All right. I believe that looks about right. So now for volatility, we are going to do a similar process. Returns is just equal to results.returns. Oh, and same thing here, backtest. And then our mean is just equal to, once again, this the sum of returns over the len of returns. And then we can just do for return or we could just do for R and returns. Oh, I forgot my colon. For R and returns, it is just we do not want to. Volatility is the square root of this. Another thing is that this was an inefficient version because we're storing all the standard deviations in a list when we can just sum them. So so our returns is still our returns and our mean is still the same, but our total is 0, and it's for R and returns. Total plus equal that, and move that, and then variance is just equal to our total over len returns, and then Q. I believe that I need to import math real quick. Import math, lowercase m, because I have fucking slash in there. Papa. It's math square root. Yeah, should be right. Then let's do that again. Awesome. So now we have that. Now we have that figured out. Let's also clean this up a little bit. Separate the for loop just a little bit. Space. And all right, next is our num of trades. So next is our number of trades. So this one is just going to count the amount of times our strategy will trade. Positions is equal to results dot positions, and once again, just make sure this is backtest results, and then so it's for I in range 1 comma len positions. So it's just going through the positions there, and so we'll do num trades is just equal to 0 there, and we'll just do if positions of I does not equal to positions shoot chat, and then of I minus 1. We'll just do num trades plus equals 1. And then just turn our num trades. That one's not too hard, I don't think. Oh, got to add this number of trades is num trades results. All right, one more time. One trade, and that would make sense because our strategy one was the always in strategy, so it just buys in that first time and it doesn't trade again. Alrighty, and then our last one is our exposure. So this one is basically just how long we are bought in. So this one I don't think is going to be, this one's not too bad because it's just so this one's a similar one. So it's positions equal to, oh, and also you do that thing again. Backtest results. is equal to results dot positions, and then we just do the sum of positions over the len of positions. And this is basically just, since our positions are always 0 for not in or 1 for in, if you just sum our positions, it just gives you the amount of times that you're in, and our len positions gives you the amount of time, like it's just the overall positions that you have, which should be just 20 because it's the length of the bars. And then just wire that into our summarize, which gives us exposure, and then exposure, and results. And let's do it. And our exposure is 95%, so that means it's basically always in. And let me do the len of positions -1, because I don't think that first one should count. Awesome. And that is that's a pretty good start for our metrics, and we can move on to a proper print. Now that we have all of our new metrics, new fancy metrics for our backtesting, we now need to make a change to our pipeline. So our pipeline currently just has all of these different strategies and a bunch of just debug statements that used to just be kind of messy and you know, kind of all over the place. So I made a new file called reporting.py, and it's going in our utils folder. And this is going to basically do, this is going to print. This is going to be where we get the function to print our new metrics. So first, let's just start with naming the function print summary. And I misclicked print summary. It's going to be, we need the name because we're going to name the functions later, and the summary for each function. And then we just need to print our strategy name, strategy, and the name of the strategy, and then give it some buffer of about, we'll do 10 now. See how it looks like, and then and a summary dot items is instance value comma float, and that's basically just saying if our value is a float, then we are going to we're going to print the key and our value with 4 decimal points. That's just to, again, keep everything nice and readable. And then else, we're just going to do a simple print of the key. Geez, if I could type. And our value. All right, next, let's chop all of this down, and here we go. Our new strategies is just going to be this dictionary. We have our alternating strategy. Which one? So strategy. Yeah, we'll start with our alternating strategy, which is alternating strategy, and our always in. It's in strategy. And then we also need to, from reporting.py, it's going to be src.reporting or src.utils up that reporting. Import, what's it called? Print summary. Positions, comma, initial capital, comma, trade cost. And then strategy, just do that, strategy, comma, or summary is equal to summarize results, print summary, name, comma, strategy, summary. And then let's rerun that. Awesome. Yeah, that looks really good. And let's change that. We'll go up to 20. 30, maybe? Awesome. Maybe we'll even do 35. Yeah, that looks really good. So, awesome. So yeah, our new strategies. So our equity, our final equity is checked, our total return, our drawdown, mean return, volatility, number of trades, and exposure. And we're gonna have to make some changes to our mean return and our volatility. Just because it's tracking the market, not not the strategy itself based on position. So those are going to be some changes that we have to make as well. So to make the change for our mean return and our volatility, which uses the actual returns and like returns themselves, what we're going to do instead is we're going to get our strategy returns. And we're just going to throw in the results. Returns. So what we're going to do is strategy returns is equal to this empty list for I in range, comma, then result dot equity step is equal to result dot equity over results -1 -1 strategy turns append step return strategy returns. See how this runs. It looks good. One last thing I want to add to our metrics is a quant metric that is a bit different in nature than the rest of them. It's called the Sharpe ratio. We're only I'm only going to do a sharp like because since the data is fake, you cannot get a true sharp ratio. So we'll just do a sharp like of results. We'll just use the mean. It's just equal to mean return results and volatility since is equal to volatility results, and we return mean over return. Crazy. And then just add that here. Our sharp like ratio is just sharp like of results. White. And then let's run that. Awesome. So this is and so essentially what the sharp like ratio means is your average return over the volatility, which is essentially just how much are you getting, like how much return are you expected to get for the risk that you took. So if you have a really high, a really positive Sharpe ratio, that essentially means that that you got a lot of return in comparison to the risk that it took um, to get that return. And if you have a Sharpe ratio of 0, that means you didn't get much return for the risk that you took. And if it's negative, that means you got your returns were terrible for the risk that it took to get there, which essentially just means like if you have a high volatility or a lot of variance, that means it's very risky usually, and especially if you get negative returns, your Sharpe ratio is going to be terrible. Is going to be bad as a result, and that's essentially all this Sharpe ratio is measuring. So now I want to add a more realistic strategy other than these fake strategies here. So for the next function, the next thing we're going to add is we're just going to do a momentum strategy. So let's call it if momentum strategy. So passive bars, list bar, and we'll output list of integers again. So positions is equal to 0. And then for change, and we actually need an I here since we are using past bar data. So len bars, and then we'll do if I minus 2 is less than 0. So that means if it should really only do that for the first bar, because we don't want to allow it to see the current bar. So we're going to do I minus 2 and I minus, or the comparison between I minus 2 and I minus 1. So, but if it's negative, it's going to look back at the ending bars, not the beginning bars. So if I minus 2 is less than 0, and then position dot position of I, or positions I equal to 0. Bad typing. then else if close I minus 1, where it's bars dot close is greater than bars dot close of I minus 2. Positions I is equal to 1, else positions I is equal to. So the changes that we are looking for here is that I made a mistake here, and we want to look at the specific bar I minus 1, and then that's the closed position. So changes bars of I minus 2 there, and that's now it's highlighted blue, so it's looking good. Do positions dot append 0. So we're wanting to append it. Positions dot append 1. Positions dot append and then now we just have to get back to our run pipeline. We need to momentum strategy. Call this momentum ret strategy. Then let's see. I gotta go back. Strategy. Is it looking? Oh, it's because, duh. I'm not returning my positions. There we go. Okay, so our momentum strategy sucked somehow, like really bad, which is a bit unexpected. C++ to get data. I have downloaded data from Fidelity online for 5-minute bars, and we're gonna have C++ parse that data and clean it up and normalize it. So far we're gonna add a new file, CSV reader.hpp, and then file, we're gonna do normalizer.hpp, and we're gonna have the validator.hpp. And then in our source file, we're gonna call this main.cpp. Then we're gonna have the CSV reader.cpp. We're gonna have the normalizer. CPP. And the validator.cpp. So this CSV reader will just read, oh, I forgot, it's this one. Read raw CSV and return rows as strings. Our normalizer will convert raw row to a cleaned struct. And a validator will enforce rule for structure norms. And then runs CPP data pipeline. So guys, that's gonna call it. I'm gonna call it for this video. Thanks for watching, and our next episode will be going over the data implementation and collection with C++. I currently have the full files up here. I created them already. I may or may not show that in the video, but in essence, I am going to take massive amounts of data from Fidelity and process it with CPP, and then feed it to Python for the backtesting and simulation. That'll be covered in my next video. Thanks for watching. Please hit the like and subscribe button if you enjoyed this video, and I will catch you guys in the next one. Peace.